Okay. If we remember that whenever we're asked to write an equation of a line, we want to put it in what we call the y equals mx plus b form. And there are going to be two numbers that I have to worry about, the m and the b. Now, the m is what we call the slope, and the b is the y-intercept. And whenever we go to write the equation of the line, the first thing we want to do is remember or work on finding the slope. Sometimes they give us the slope, but the first thing that we're looking for is the slope. Now, in this case, they told us 2 points on the line. One point is the point 3, -7. The other is the point 0, -2. So if you remember and you must remember this formula, very important formula, the slope formula is y2 minus y1 over x2 minus x1. Where one of your points you're going to call your x1, y1. Those little numbers just indicate x of the first point. x1 is the x of the 1 point, and y1 is the y of the 1 point. And this, your second point, just call your x2, y2, and then just put in the numbers. The y2 I see is -2, minus the y1, which is minus -7, over x2, which is 0, minus 3. Okay. Now you could, if you want, stick this into your calculator. If you're doing it in your calculator, you have to do the top separately and the bottom separately, because you want it as a separate fraction. You would do -2 minus, and this is the subtraction button, -7. This is the negative button. Now, if you're doing it, and you should get 5. If you remember, when you have two negatives, it becomes the two negatives turn to pluses, and really this becomes -2 plus 7, which is +5. And on the bottom, 0 minus 3 is just -3. So our slope for this equation is going to be -5/3. Remember, when there's a negative in a fraction, it could either be on the top or on the bottom or in front. They all mean the same thing. It doesn't matter. You can move this negative around, but it's not two negatives. It's just one negative in front, or one on top, or one on bottom. And if you notice, if I look at my choices right now, I really would know that I'd have to pick choice C. Why? Because here the slope is 5/3, and we need it to be -5/3. Here the slope is 5. Well, that's no good. Here the slope is -5/3, so that's good. And this is the slope is -5. So there's only one that has the correct slope. So really, right now, I could just go and pick the right answer. But just to remember, if you were doing this on a Delta math, you'd have to do this not as a multiple choice, but as a open-ended question. So let's just remember how to figure it out if you want to do this using just working the rest of it out. We're now at the point that we know that y equals -5/3 x plus b. We filled in the slope. We know the slope is -5/3, so my equation now, the m, is -5/3. Now I can take either one of these points and fill it in for the x and the y. in my equation, as long as I take the point together and put the first number in place of the x and the second number in place of the y, I'll get a true statement. And since I now, usually they only give me 1 point, but in this case, they gave me 2 points. I have my choice to either pick this point to stick in or this point to stick in. And if I look at this, this really looks like easier numbers. So I'm going to take this one. But if you try the other one, it would work as well. So that means where I see an x, I'm going to put a 0. Remember to put the x over here. And where I see the y, I'm going to put the -2. Don't mix it up. So this will become -2 equals -5/3 times 0. Well, anything times 0 is going to be 0. That's an easy multiplication. Again, if it's not such an easy multiplication, you could do it on your calculator. Let's say you wanted to do -5/3 times 3. Then you would do -5 divided by 3 on your calculator times 3 and press equal, and it'll give you the answer. Make sure you're okay with using your calculator. But in this case, this was a 0. 0 times anything is 0. Plus the b, obviously the 0 cancels out, and we get b equals -2. So therefore, my equation becomes y equals -5/3 x minus 2, which again is choice C. Sometimes when they give you the choices, they only give you one right answer with the slope. Then you don't have to go any further. But if they would have given me 2 right answers, 2 answers with the same slope, I would have had to find out the B for sure, because I'm not sure which one is the right answer. But in this case, I really didn't have to go any further than finding the slope, because this was the only one that had the right slope for this answer. Does anybody have any more questions before I go on? Okay.
No, there's no questions. But yesterday, Miss, I literally forgot that we were going by a Monday schedule. So I didn't even log in yesterday. And I went to school to go to my classes, and there wasn't even no classes. And I realized wow, it's a Monday schedule.
I sent an email 3 times.
I know.
You have to check the emails, check the schedule. I specifically, I even bolded the fact that it's Thursday. I think on Wednesday, I did say I did say that we have class. I mean, I tried to make it very clear. I won't hold you, just, it would be a good idea if you would look at the recording. I don't know if I posted it yet, but I'll certainly post it today. There'll be a recording for today and tomorrow. So you'll be able to see what you missed. Okay? I think this is the only day this term that this happens. I think all the other days are just regular. Though next week, there is no session on Wednesday. And the following week, there's no session on Monday because it's Columbus Day. On the 11th, I think it's. So the next couple of weeks, we only have 2 days. But at the end of the lesson, I'll talk to you about the scheduling. Okay. Now, Mariana, you asked me if we could do one more like this. Okay, let me do one that's a little bit different, but on the same idea. Let me see if I can find one. Again, I'd like to find one from a final or a midterm or a final, because I think those are indicative of the type that you should be able to do. Okay, here's the question. Again, it's going to be write an equation of the line. So we want to write the equation of the line that's parallel to the line y equals y plus 7x equals 3, and passing through the point (0, -3). Okay, and again, I'm going to give you choices. It's a final exam problem, so it came with choices. Okay, those are the choices of your answers. And see, one person has answered the question. Okay, Kayla also answered the question. Okay, I'm giving you one more minute and then we're going to do it together. Okay, and Oriana, I guess we can get started. Good. I have a couple of answers, not all of them agree, but I'm putting down who put down answers. Again, I have a list already. Some people already have 5 extra credit points. In the end, I'll let you know how we're going to use it. Okay, Emma, great. You also came up with D. Okay, so let's see how this works. Again, they gave me that we have this equation y plus 7x equals 3. And we want to write the equation of a line that's parallel to this line and goes through point 0, -3. So what we have to remember, we're trying to write something in the form, writing an equation of a line, we want to write something in the form y equals mx plus b. Which means that we want to first find the slope of this line that I'm talking about, and then we want to find the b. So let's call this line 1 the original line, and line 2 is a line that we wanted. There are 2 different lines being talked about here. That's what sometimes makes this confusing, because there are 2 lines here. There's an original line that they gave us the equation of, and then there's this new line that we want to write the equation of that's parallel to this original line. And we remember that when we use the word parallel, it means that the lines have the same slope. By using the word parallel or the word perpendicular, those are indications of the slope. When the lines are parallel, the slopes are exactly the same. But when the lines are perpendicular, the slopes are opposite sign, and reciprocals. You flip it over, you'd have to take the slope and flip it over and change its sign. But we're not talking about perpendicular here. Now we're talking about parallel. So the 2 lines are going to have the exact same slope. So I look at this and I ask, what is the slope of this line? And I can't figure out the slope of the line until I put the line in the y equals mx plus b form. I have to have the y by itself, which means I have to get this 7x to the other side, which will give me y equals -7x plus 3. Okay, so anytime I'm looking for the slope, and I don't have points, but I have the equation, I have to put it in the y equals mx plus b form, and then I have to look at the number that's right in front of the x, which is -7, and the slope of my original line is -7. Therefore, my new line will also have a slope of -7, and so this will give me y equals -7x plus b. The 2 lines are parallel, they're going to have the exact same slope. Now, if I look at this, there are 2 choices that have slope of -7. There's choice A and there's choice D. Notice choice B has a slope of +7, and our original line has a slope of -7, so our new line has to have a slope of -7. Be very careful with those signs. Okay, so the question is the choice A or choice D going to be the right answer? Well, in order to do that, we should take the point that we were given and substitute it. And we know that the y is -3 when the x is 0, because it goes through the point 0, -3, which gives me -3 equals, well, anything times 0, -7 times 0 is 0, plus b, which again makes my b equal to -3. So my equation then is -7x minus 3. Actually, I could have just seen that the b right away is -3, because when the x value is 0, the number next to it, the y value, is the y-intercept. So we would know that -3 is a y-intercept, but it works this way as well. And therefore, this is not the right choice. And yes, those people picked D, you got it right. Any questions now? I think we should go back to what we were talking about the other day. Okay, I think most people did get these right. I think it's easier, obviously it's easier to do these, it will be easier, let's say, on the midterm to do a question of this nature than on the Delta math, though I would like you to keep practicing on the Delta math. Just keep doing it. You get credit for however much you do. There's going to be a quiz on Delta math. I'll tell you when I want you to do it. That will be on chapters 2 and 3. So I will those questions might be a little bit harder. On each question, I'm giving you the chance of doing it twice. Again, if you don't do well on a quiz, the Delta math tests are really quizzes, then I can always reset it for you and you could do it another time. You want to do this because you want to be able to do the problems. I can't allow you to take a midterm or a final a second time, but I certainly can give you the ability to change to get a better mark if you're not happy with your Delta math marks. So you can always, don't neglect the homework and don't neglect the quizzes. Most people are being okay about doing it, but there are some people who have not been up to par. Okay, so let's go back to systems of equations. The last thing we were talking about was what we call applications of systems of equations, where we are given a word problem and we have to write in a system of equations and then solve the system. So I'm going to give you again one that coming off of a final. I want you to see that what we're doing is really pertinent. You really have to know this stuff. Okay, and here's the question. There were 680 people at a play. Okay, a total of 680 people went to a play. The admission price was $2 for adults. And $1 for children. And the admission receipts, the total amount of money they got was $1,010. And we want to know how many adults and how many children attended. And again, this is a multiple choice question, so I will write the answers over here. And let's see if you can come up with the right answer. Okay. Choice A is 350 adults. 330 children. Choice B is 330 adults and 350 children. C is 175 adults and 505 children. And the last choice is 252 adults and 428 children. Okay, let's see if you can come up with the right answer for this example. Okay, I'm gonna be taking attendance while you're doing this problem. Olivia. Isis,
Good morning, I'm here.
good morning. Alvaro. Lewis.
Here. Good
Hi,
morning.
good morning. Emma,
I'm here. Good morning.
good morning. Demetrius. Desmond. Desmond Fleming. Shania. I think Shania told me she was here before. Kayla, I know you're here. Sanjita. Ariana, I know you're here. Tahira, I know you're here. Michaela. Michaela. Kiana. Carly. Jenna. Tatiana. Naya, I know you're here.
Good morning.
Good morning. Kazandu. Trina. Trina. Jean. Yes, it was hard to get up today. Okay. Did we try working the equations? Let's set up the equations. And then I'll give you time after the equations are set up. Let's see if you can solve it then. But let's work on, I see we need a little bit more work on this. We'll do this one, we'll do another one. Okay, so we have a total of 680 people going to a play. And there's obviously a charge for the play. It's $2 for the adults and $1 for the children. And the total amount of money that they collected for this play is $1,010. And they asked how many of the people, the 680 people, there are two types, there's adults and children, how many were children and how many were adults? So we're going to first set up what we want our variables to be. I'm going to use X and Y, but we could have used A and C for adult and children if that's makes it more. So you could do either way. You could do any letters you want. So let's call X the number of adults that attended this play. And let's call Y the number of children that did. I always like to write it down. This is called writing a legend. But really, I like to write down what my variables represent. So I know exactly, and I'm clear in my mind what I want to write. Okay. Now, X is how many adults there are, and Y is how many children there are. That together is all the people together. So that's where this 680 has to come into play. We don't, the 680 has nothing to do with money. It's just how many there are. So we know that our first equation is going to be X plus Y equals 680. The X and the Y are just the number of people. It has nothing to do with how much money they spent to get into this place. So there, we do the 680 that has nothing to do with the money. So our first equation is just how many people there were. The second equation has to do with how much was spent, how much money came in. Well, we know each adult paid $2. So the total amount of money they got from the adults was 2x. X is how many adults there are, multiplied by 2, and that's how much money the adults brought in or paid to get in. The children only paid $1, so it's 1 times Y is how much money the children came in from the children. So the 2x plus the 1y, that's going to give me the $1,010. Notice where I stick in the money, I have to go to the money. The money is here, the 10, so therefore I put it in the equation that included the price. Okay, now here is our system of equation. Let's see if you could solve it from here. I'm going to give you a few minutes and more to see if you come up with one of these answers. And again, you could pick A, B, C, or D. All right, let's see if we can work it. I guess you're having a little bit of a hard time with this, so let's see if we can do it. Okay, let's look at our system of equations. Remember, we want either, it's set up x's, y's equals numbers, what we call standard form. So usually in the standard form, we use the addition or elimination method. Let's see if we can eliminate the x's. Doesn't matter which we decide, let's decide to eliminate the x's. So remember how we do that. You multiply each equation by its opposite coefficient. So this is obviously a 1, it's understood to be a 1. It's like this is a 1 and this is a 1. But this coefficient is 2, so I'm going to multiply the top equation by 2 and the bottom equation by 1. But we also know that what we have to have is that one of the variables has to have a negative and one has to have a positive. Now, both of these happen to be positive. So since both of them are positive, we're going to have to use a negative when we multiply. When we're deciding what to multiply by, we first just pick the numbers. without any plus or minus sign. We just put positive numbers. And after I've decided what numbers to use, then I decide if I have to use a plus, a minus or not. If one of the variables is plus and one is minus, then I just multiply by the positive numbers, just the regular numbers, because it already has the signs that I want. I want to end up one being positive and one being negative. But if they're both plus or they're both minus, then I'm going to have to use a minus with one of the numbers I'm multiplying by. And it doesn't matter which one you use. So either you're using two positive numbers or just two numbers without any sign, or you're using one negative number and one positive. You're never using two negatives. You're always using either both positive or one positive and one negative. Okay, multiplying the first equation by -2 will give us -2x, and -2 times y is -2y equals 680 times -2. So I'm going to take out my calculator and do it on my calculator. Okay, and this gives me -1380. I'm sorry, -1360. Okay. The bottom equation, we're multiplying by 1. Well, when you multiply by 1, you're not doing anything, you're just repeating it. Okay, now we're adding. -2x plus 2x, that's the whole point. We wanted to get rid of the x's. We wanted to eliminate the x's. So that's eliminated. Here we're getting -2y plus 1y, which gives me -y or -1y. And -1360 plus 1010 is giving me -350. And I'll divide by -1 because I want what y is, and I get that y equals 350. Now y stands for the children. So I have to look for an answer that gives me that the children are 350. Now that has to be choice B. Don't mix up. A has the adults being 350. If we had wanted to do this as an open-ended question, we could have gone back to this equation. X plus y equals 680. And since we now know that the y is 350, we're going to get x plus 350 equals 680. And when I subtract the 350, I'm getting 330 as the x, which is the adult. See, it was a good idea that I wrote down which was my x and which was my y, because when I get to y equals 350 and I forgot that the y is the children and I think it's the adult, I would have picked choice A. And I would have done all the work correctly, but I still would have been wrong because I had made the wrong choice. Okay, I'm going to put another question on the board. Yeah, we're going to do another one right now. And we'll see how that one goes. I'm going to put one on the board. It's going to be a slightly different scenario, but the setup is going to be the same. This one is not a multiple choice. This is an open-ended question. It actually is on the question sheet. I have too many papers here. Okay, here's the question. If this happens to be question number 9 on their practice sheet. Again, that's the sheet that comes straight from the department. So it's the type of question you would like to know. Okay, here's the scenario. Here's the story. Chad sold 30 decorated sweatshirts at a craft show. White ones cost $10 and black ones cost $15. He received a total of $390 for the shirts. How many black shirts did he sell? Okay, I'm going to read it again and write the important information again. Chad sold a total of 30 sweatshirts. He had 2 types. He had white ones, for which he charged $10 a piece. And he had black ones, for which he's charging $15 a piece. So the $10 is how much each one individually cost, sort of like when we gave the price of what the tickets were. He received a total, this is how much money he made altogether. He made a total of $390. And we want to know how many black shirts did he sell? And by the way, I'm not going to write this 10.00. I'm just going to write this as $10. And this I'm going to write as $15 because it's just easier not to have all those decimal points. I don't think we need them. So let's go through it again. We have a total of 30 shirts being sold. The white ones for $10 each, the black ones $15 each. And the total amount of money that he's getting in for selling these sweatshirts is $390. And we want to know how many of the shirts that he sold were black shirts. Okay, so we're going to do this. I'm going to give you a few minutes to think of if you can write the equation, and then we're going to see if we can solve it. All right, let's see if we can work on this together. Okay, so let's see what we're talking about. We have two different types of things to talk about. We have white shirts. Should we call that W for the white shirts? That's enough. Let W be the number of white shirts he's going to be selling. And let B be the number of black shirts. So white is the number of white shirts sold. And B is the number of black shirts sold. Notice I don't just say let W equals white. Because there are a lot of things that could go on with the white shirts. It could be the price, it could be how many there are, it could be what color they are. So I'm being really specific. When I use W, I mean it to mean how many white shirts were sold, and B stands for how many black shirts were sold. And remember, the question was, and we always let the question indicate what my unknowns are going to be. This is what I'm looking for. I'm looking for B, because I'm looking for the number of black shirts being sold. But we first have to write the system of equations. So again, the fact that 30 sweatshirts was sold just tells us how many. It has nothing to do with money, how much they cost at all. So let's just use, that gives us the equation W plus B equals 30. Because W is how many white shirts there are, sweatshirts, and B is how many black shirts, sweatshirts there are. And there are a total of 30 sweatshirts sold. So our first equation becomes W plus B equals 30. Similar to what we did before when we said children's tickets and adults tickets, and it didn't have anything to do with the price. We just said how many were sold. That's our first equation. That's what we usually write. Our second equation, we're going to throw in the price of the sweatshirts. So the price of the white sweatshirts is $10. So for the white sweatshirts, the amount of money you're making is how many there are times 10. Like if there are 10 white shirts, then you're getting 10 times 10 or $100 for the white sweatshirts. But for the black sweatshirts, we're getting $15, so that becomes 15B. And that, the 10W plus the 15B, which is including the money, will give us the total amount of money we made, which is $390. And here is our system of equations. And now we want to solve this system of equations. Specifically, we're looking for how many black sweatshirts were sold. So really, when I know which of the variables I want, I'm going to try and get rid of the other one. I'm going to try and get rid of the W's so I can be left with the B's, because that's what I'm looking for. If you get rid of the B's, or the X's or the Y's or whatever you're calling it, and it's make sure you when you get your final answer, that's why I write this legend here, that I know that what I'm getting is what they're asking for. If I get what W equals, that's a good answer, but it's not the answer to what they asked. So make sure you're answering the question as it's asked. Okay, we know we want to get B, so we're going to get rid of W, which means the top equation I'm going to multiply by 10, and the bottom equation I'm going to multiply by 1. But again, they're both positive, so I have to use a negative in one of them. Let's say you use a negative on the second one. It doesn't matter, just a negative with one of them. Okay, so let's see what my equations are going to turn out to be. Multiplying the top equation by 10, I'm going to get 10W plus 10B equals 10 times 30, which is 300. And the bottom equation is going to become negative 10W minus 15B equals negative 390. Okay, and now when we'll add them, remember that the point of it is that we want to get rid of the W's, and we will, because a positive 10W combined with a negative 10W cancels out. It's eliminated. So then we have 10B minus 15B, which gives me negative 5B. And 300 minus 390 gives me negative 90. And I have to divide by negative 5 to get the answer. And you can do this on your calculator. Negative 90 divided by negative 5 is 18. He sold 18 black sweatshirts. You could also figure out how many white sweatshirts he sold, but they only asked us how many black. Does that make it a little bit clearer as to how to go about setting up these equations? Okay. The only thing that we can do is keep reviewing. And before I go on to something else, I just want to make an announcement to you. The next couple of weeks, I am not going to be here. I'm not going to be here for the next 6 sessions. But we're very lucky. We have our master tutor, Patrice. Patrice Williams is going to be taking over for the next, as I said, next 6 lessons. I am going to be gone until October 21st. So Patrice is going to be taking over the 2 lessons that are next week. Remember, October 5th, there's no lesson. There's no, the school is, I don't know if the school's closed, but there's no classes. No classes at all scheduled for the 5th. And again, the following week, no classes are scheduled for the 10th. That is Columbus Day. I think the school is actually closed on that day. And so there'll be 2 classes next week, 2 classes the following week, and Monday and Wednesday of the week after that, I will be back on Friday, 3 weeks from today. As I said, Patrice is going to be continuing the class, and I'm going to give you her login number. There's going to be a different ID for the Zoom. It's going to be sent out on an email, but I'm going to write it right now on the board. And then I'm going to ask Patrice if she wants to say anything to you in terms of what's going to be going forward. Okay, so here is for the next 6 sessions until this is through 10/19. You're going to be using this ID for the Zoom. Your ID is going to be 838 5181 70110. And the passcode is 967339. And this is what you're going to use as your Zoom login for the next 6 sessions. Patrice, you want to have any comments?
Oh, not really, except that we'll just be using the built-in whiteboard instead. We'll be doing the same thing, and I'll put the schedule up also on Blackboard, so it'll be recurring. So they can always just sign in from Blackboard.
Yeah. Okay, so, and it will be sent out, it's gonna be posted on Blackboard,
Yeah,
this information and it's also gonna be sent out as an email.
Yeah.
So, and are you gonna be sending them out emails each morning the way I do?
we'll keep it the same. Yes, I will.
Okay, so she's gonna be, so you can, if you forget, but just remember, this starts this coming Monday, you're going to be logging on with Patrice.
Yeah.
Okay. Are there any other questions? I see somebody else, if there's it'll be sent out in an email, yes. Okay, okay, so let's just start the next. One of the things Patrice is going to be doing is she's going to be reviewing all the things that we've covered so far. And of course, she's going to be going forward on chapter 4. I'm just going to be starting the beginning of chapter 4 and just introducing it and reminding you of things that I think you probably already know. I think that you might find this chapter a little bit more familiar with what you're used to. So what chapter 4 is called is polynomials. We've been working with equations and actually started our whole semester how to solve equations. So where do polynomials come into and what do they mean? So you might see an expression that looks like this. 3x to the 4th minus 5x. Third plus 7x squared minus 5x plus 2. Let's say you might see something like that. Or you might see something like this. 7x squared y minus 5xy squared. Both of these are what we call examples of polynomials. A polynomial is an expression, an algebraic expression, where you have more than one term. Now, what consists of a single term in algebra? It's anything that's connected only by multiplication. And remember, exponents are considered part of multiplication. For example, one term of this top polynomial is 3x to the 4th, because everything here is connected by multiplication. The minus 5x cubed, that's a different term because it's separated. Anytime you have more than one term, they're going to be separated either by a plus or a minus. In this case, we have 1, 2, 3, 4, 5 terms. That is called a polynomial. If we have only one term, it's called a monomial. But more than one term is a polynomial. Actually, this one has 2 terms. This is called also a polynomial, but sometimes specifically called a binomial. So a two-termed expression will be called a binomial. A three-termed expression will be called a trinomial. Any others are just called generic polynomials. So all these are polynomials, but if you have specifically only two terms, it's going to be called a binomial. If you're going to have exactly three terms, you're going to have a trinomial. Otherwise, it's just going to be called a binomial. Now, the question is, first of all, let's talk about this. When you have just one variable, like this in this first example, here we have two variables, but let's talk, we only have one variable, then we can talk about the degree of the polynomial, which is the highest exponent you see. In this case, we see an exponent of 4, an exponent of 3, an exponent of 2. Remember, if there's no exponent on the variable, the exponent is 1. And here there's no x at all, so really it has an exponent of 0. It doesn't have any x. So the highest exponent we're seeing happens to be equal to 4. This is a 4th degree polynomial. We're not going to worry about it when we have more than one term. There are ways of expressing those degrees, but we don't talk about it too much. Remember when we talked about having linear equations, and I said it's sometimes called a first degree equation, the degree being the highest exponent. When there's the highest exponent, when there's no exponent, means the highest exponent is 1, then it's a degree 1 or first degree. This is a 4th degree polynomial. Now, one of the major things that we like to do with polynomials is to sort of simplify or combine polynomials, but we can only combine terms. Remember, a term is one of the it's just one of the terms, one of the expressions that is all by itself. So the only type of terms we can combine are something called like. So what do we mean when we can only combine like terms? Let's say I have something like this. 7x squared y plus 15x squared y. If I look at the letter part, the variable part of the expression, if they're both identical, this is x squared y, this also says x squared y. Those are like terms. If we have like terms, then we can combine the coefficients. Then we, depending on what the sign is, we either add or subtract the first numbers, the numbers in front. This is a 7x squared y plus a 15x squared y. We add the 7 and the 15, and we get 22x squared y. Notice when we are combining, which means either adding or subtracting of polynomials, we only add the numbers in front. We don't change the letters, and we can only add the terms if they are like terms, if the letter parts are identical. Notice over here in choice 2, this said 7x squared y minus 5xy squared. Even though they both have the same letters, they don't have the same exponents. Here the x has an exponent of 2, and here it only has an exponent of 1. And the y here has an exponent of 1, and the here it has an exponent of 2. In order to be like terms, the letters and their exponents have to be identical. If they are, you can combine them. If they're not, that's as simple as you can get. Over here, we can't simplify anymore. The same thing over here. These are not like terms because even though the 4 of them all have x's, the x's are not the same exponent. You can't combine something like an x fourth with something like an x third. You can only combine x fourth with x fourth or x third with x third. You can only combine like terms. So let's see if I gave you. Suppose I asked you to add these two polynomials. I'm going to add 5x squared minus 4x plus 2 plus my second polynomial is 3x squared minus 9x plus 7. Let me show you how I think this should be done. First of all, as usual, we want to remove parentheses. If we have two things in parentheses, we want to remove the parentheses. And we remove parentheses by multiplying by the number that's in front of the parentheses. In this case, there's no number in front of the parentheses, so it's understood as if there's a 1. And in front of this one, it's also understood as if there's a 1. So I'm going to multiply the first parentheses by 1, which means it's just going to stay 5x squared minus 4x plus 2. And then I'm going to multiply the second parentheses also by a plus 1. So it's also going to stay the same. It's going to be plus 3x squared minus 9x plus 7. Now, when you have no any parentheses or brackets or anything, we remove the parentheses. We're going to look to see if we have any like terms to combine. So my first term I see is a 5x squared. The only thing I can combine at 5x squared with is other x squared terms. So here's my x squared term. My next x squared term is this 3x squared. Nothing else is an x squared. Those are the like terms. I can add 5x squared plus 3x squared. And always keep in mind the sign is always what's in front of it, not what's after it. This is a positive 5x and a positive 3x, a 5x squared and a 3x squared. So when I add 5 plus 3, I get 8x squared. That takes care of the x squared. So then I go to the x's. So here I'm going to use a different symbol. Here's a negative 4x. And the other thing that has only a plain x is the negative 9x. Again, those are like terms. So those can be combined. So negative 4x and negative 9x together give me negative 13x. Notice when I'm combining, I just combine the numbers in the front. I leave the letters. I leave them untouched. They're going to both have the same letter, and that's what it's going to stay. This is x squared, the answer is x squared. This is x, the answer has an x. Finally, we have the 2 and the 7. And those are like terms also because they don't have any x's. So we're gonna do 2 plus 7, and that's gonna give me 9. And now I have combined these two polynomials. They were both trinomials. This was a trinomial, this was a trinomial. My answer also turned out to be a trinomial. We had 3 terms in my answer. Let's do one with a subtraction, and then I'll give you one to try on your own. Well, here's my next question. This is actually on a final exam. We have 8x squared minus 4x plus 4 minus negative 2x squared plus 3x minus 7. Okay, and these are again 2 trinomials that we want to combine the like terms on. But again, we have to get rid of those parentheses. So again, this is as if there's, remember, there's no number in front of them, so it's as if there's a 1 there. Don't forget, when you don't have a number in front of a variable, like in front of an x, or in front of a parentheses, it's not like it's there's no number there. It's understood to be a 1. Okay, multiplying the first parenthesis by 1, we get 8x squared minus 4x plus 4. Multiplying our second in parentheses now by negative 1. Negative 1 times negative 2x squared is plus 2x squared. Negative 1 times 3x is negative 3x. And negative 1 times negative 7 is plus 7. Notice when you're multiplying it, you can think about it. All you're doing when you're multiplying by a negative number, negative 1, is you're changing all the signs. When you're multiplying by plus 1, you're not changing anything. But when you're multiplying by negative 1, all the signs get changed. And now we're going to do what we did before. We're going to look for the like terms. So here there's an 8x squared that we can combine with a positive 2x squared. So 8 plus 2, remember, I just take the numbers in front. I add them, 8 plus 2 is 10, so that's 10x squared. Then we have negative 4x and negative 3x. When we combine them, that gives me negative 7x. And finally, positive 4 plus positive 7 gives me positive 11. Again, if you're having trouble with the signs, use your calculator to help you so you get the right answer, so you don't make mistakes on the signs, where the rest is relatively easy. That's what's called adding and subtracting of polynomials. I think I'm going to stop right here because this is where Patrice is going to take over. She's going to be continuing with this chapter 4. I think you're going to like it better than the other chapters. Again, it's a little bit more direct, so you might find it a little bit easier than what we've been doing before. Does anybody have any questions they want to ask me?